Hello everyone, welcome back to my YouTube channel. I am Tejas, studying history and Teacher College of Engineering, branch Computer Science Engineering, subject Maths. Today's topic is Introduction to Bisection Method. Introduction to bisection method. The bisection method is a simple and robust numerical technique used to find the roots of a continuous function within a given interval. It involves a repeatedly bisecting the interval and thus selecting the subinterval in which the root must lie. Understanding the bisection method. Step 1. Identify the interval A B where the function changes sign, indicating the presence of a root. Step 2. Calculate the midpoint C is equals to A plus B divided by 2 of the interval. Step 3. Evaluate the function at the midpoint C and determine which subinterval contains the root. These are the steps for the understanding of the bisection method in the maths. Advantages of the bisection method. The bisection method is guaranteed to coverage to a root as long as the root is located within the initial interval. The method is relatively insensitive to a small changes in the function or the initial interval, making it a reliable choice. Simplicity. The algorithm is straightforward and easy to implement, making it a popular choice for beginners. The main advantage of this bisection method is the simplicity of the bisection method because it is easy, so the all beginner can use this method and solve the problems very easily because this is user friendly and the algorithm also a straightforward and easy to implement. These are the advantages of the bisection method. Limitation of the bisection method. The bisection method has a linear rate of coverage, which can be slower compared to other fruit finding methods. Requires the function sign change. The method requires the function to change the sign within the initial interval, limiting its applicability. Limited precision. The bisection method can only achieve a precision limited by a machine floating point representations. These are the limitations of the bisection method. These are the main reasons because of which we are not using the bisection method so much. Step by step explanation of the bisection method. Step 1. Initialize the interval AB where the root is known to be lie. Step 2. Calculate the midpoint. C is equals to A plus B divided by square of the interval. Step 3. Evaluate the function at the midpoint C and determine the sign of f of C. Step 4. Step 4 is to update the interval AB based on the sign of the C to ensure the root is contained in the new subinterval. These are the steps to be followed while using the bisection method. Implementing the bisection method in the programming. Pseudocode initialize A and B and interval bounded repeated until coverages. Calculate the midpoint C and evaluate the function at the C. Update the internal A and B based on the sign of the uh, f of is equals to C. This is an example of a example in the Python for the bisection method. This is a simple algorithm by which we can calculate the problem. And another example in the programming language of JavaScript. Python is better and easy to understand to implement this bisection method. Slow coverages and bounded accuracy. Guaranteed coverages coverages, and the bisection method as a linear rate of coverages, meaning that number of the correct digits doubles with each iteration. The method can only achieve a precision limited by the machinery's floating point representation, typically around 15 to 16 digits. As long as the root is bracketed within the initial interval, the bisection method is guaranteed to a coverages to the root. Application of a bisection method: routing, finding and solving the equation, optimization, and signal processing.